In this video, we are going to show that the greatest common divisor of n cubed plus 2n, 4 and 4, and n raised to the 4 plus 3n squared plus 1 equals 1 for every positive integers n. Okay, so we might start with Euclidean algorithm for these polynomial. So let's get started. Okay, let's get started. So we start with dividing this polynomial. This is the polynomial with degree of 4, which is going to be divided by this polynomial, which is a polynomial with degrees of 3. So we start with n to the 4 plus 3n squared plus 1 equal n cubed plus 2n. Now let's have the quotient. So for this one, the quotient is going to be, so let's use long division. So we have n cubed plus 2n divide n to the 4th plus 3n squared plus 1. We start with n right here, and n times n plus 3 plus 2n becomes n squared plus 2n squared. Subtract them, then we have n squared. Okay, just n squared, right? And plus 1 here. Now, what do we have right now? We have this polynomial has less degree than this polynomial, because this one is a polynomial with degrees of 2, and our divisor has polynomial with degree of 3. So n squared plus 1 is the remainder. So we're gonna have n squared plus 1 right here. Oh, I forget to write quotient. The quotient is n. Okay, next we will divide the divisor by this remainder. So we're gonna have n cubed plus 2n equal n squared plus 1. Okay, let's find the quotient. So we're gonna have n squared plus 1 divide n cubed plus 2n. Then what do we have? We're gonna have n cubed plus n. Subtract them, we're gonna have just n. Okay, so this is our monomial, which has degrees of 1, and our divisor has degrees of 2, and the quotient is n. So this is n plus n right here. Okay, this n is now the remainder. Now we will divide this divisor n squared plus 1 by n. So we're gonna have n squared plus 1 equal n. So our n is the divisor. So once we divide n squared plus 1 by n, so what is the quotient? So we're gonna have n divide n squared plus 1. This is our n. N times n is n squared. Okay, n squared plus 0 minus 1. The remainder is 1, which has degrees of 0, while the divisor has degrees of 1. So the quotient is n, the remainder is 1. And next is we will divide n by 1. So we're going to have n equal to 1. So 1 is the divisor, so the quotient is n. Okay, great. Now we have n equal 1 times n. And we don't have the remainder. Okay, so 1 is the last remainder. This shows that the greatest common divisor of, so we gotta say by Euclidean algorithm, the greatest common divisor of n cubed plus 2n, n to the 4th plus 3n squared plus 1 equal 1. Okay, is it for all for all positive integer n. Take a look at this equation. So this equation tells us that 1 is the greatest common divisor. And as you can see, we have this equation, n equal to 1 times n, which is always true. Okay? Right? Which is always true. So this equation, I gotta say that, which is true for all positive integer n. That means that the greatest common divisor of n³ + 2n, n to the 4 plus 3n squared plus 1 equals 1 for every positive integer n. Okay? For every positive integer n. That's it. So we have shown that this the greatest common divisor of n³ + 2n, n to the 4 plus 3n squared plus 1 is 1. That's it for this video.